as one might imagine, if you're at all familiar with Dataswift and our sister organization, Hat Lab, we are all about personal data, the protection of that personal data, the ownership of that personal data, and ultimately the ethical treatment of that personal data. And so COVID-19 and this cadre of applications that have arisen from it have put an incredibly fine focus on the issue of personal data. Just this morning, I read a piece where the Israeli government has stepped into, or rather privacy organizations have pressured the Israeli government to back off on a proposal to have their Secret Service be directly involved in contact tracing. Those of you in the UK probably have paid attention to the news, some rather controversial issues around NHS and their application and personal data sharing with organizations like Microsoft and others. And so in all of this, I think the challenges are many, but the good news, the opportunity from our standpoint, is that it's caused more of the average individual, if you will, people who don't wake up every day and think about data privacy like most of us do, to take a look at what it would mean to have perhaps the most intimate of their personal data, their health data, and ultimately whether or not they have COVID-19 or have perhaps antibodies and immunity to COVID-19, that will or could impact their ability to work, their ability to be employed. You know, not to be too dark and draconian, but in some governments around the world, there are concerns, or rather there are proposals and therefore concerns that this might become part of a permanent record, that there could be bracelets, there could be other identifiers that are either digitally or physically permanent that would mark a person as less than, in the sense that they may be unemployable, they may be not permitted into certain parts of public life. And so what we're going to set out to do today is to look at some of the various approaches to this problem of balancing the sanctity of personal data and how we go about and go through life with the very understandable utility and the desire to use technology to safeguard our well-being and to get us back to life as I say, close to normal as possible, as soon as possible. And so with that, I'll turn it over to Jonathan.
Thanks very much, Sean. So it's very nice to meet you all. I'm the VP Marketing over at Dataswift, and we had extended an invitation today to the NHSX to talk through the sort of first of our two example cases today, which is the NHS track and trace application. Understandably, they're in the middle of building it and rolling it out. They've done a couple of experiments with the rollout of their application, which I will walk you through in a moment. But they were unwilling to come onto the program to sort of talk us through it in person, but they did sort of indicate to us some of the resources that we could use to dive in deeply. And so that's what we're going to do with the first application that we walk you through today. The basics of this application are that it is a cornerstone of the UK's sort of technique for managing the next phase of COVID recovery, which is that we'll be placing contact tracing at the center of a program for identifying those who have been exposed to the disease and suffered negative symptoms and caught it, and then use that sort of focal point as a way of understanding other people who have been exposed. And in a number of implementations, actually, am I sharing my screen yet, or is everyone else able to see what I'm seeing? Good. In the way that that intended strategy is supposed to function, a digital tool for doing the contact tracing was desirable. And beginning with a trial rollout last month, the NHS track and trace application was launched. It was alternatively known as the NHS COVID-19 app. The basics of this application are that its current status is that it's in between these trial phases. So it ran a trial phase in the Isle of Wight last month and is currently under review and by many accounts rebuilding, and we'll talk about that in a moment, for the next phase of its deployment. And it's being updated as the government's guidance is updated. It's a Bluetooth-based application that records the distance between phones that have the app, and for users of the app, if they are present with symptoms, then they can allow the app to inform the NHS of that information. And the last sort of basic piece of information that's important to understand about track and trace, the application, is that it's a centralized model for these kinds of applications, which means that the data that is being created by the application is stored in a central NHS controlled database in the UK, and that data is intended to be used for the NHS care management, evaluation, and research related to COVID-19. I'm going to walk through some of those basic indications of the app first, and I'm going to start with the Bluetooth aspect of it. There's a bunch of different kinds of contact tracing. Track and trace is intended to be a Bluetooth-based tool for understanding exposure, and that means that it uses the Bluetooth functionality in smartphones to record proximity to other Bluetooth-enabled smartphones that have this application. There's a couple of nuances to that feature set that are important to understand. The first is that Bluetooth itself must be enabled on the device. And for Android devices, that means that you have to explicitly turn on locations sharing as well, because the two functionalities are tied together in the Android operating system, although this application doesn't use any locations tracking. But because it uses Bluetooth and Bluetooth functionality alone, it can run safely in the background on both the Apple iOS and Android operating systems of your smartphone. And the function of that Bluetooth tracking is that while the application is on the phone and the Bluetooth setting is turned on, exchanges between a unique ID that have been created by the application and by any other applications running in the proximity designated will occur of a unique ID. So the application will have an identifier of its own, and it will exchange that identifier with other applications that are running within proximity. The second thing that it will do then is allow users of the application to begin very basic tracking of their own symptoms. And they're doing this for an explicit purpose in the NHS Track and Trace app. And that's because, or the purpose for that is to be able to alert the NHS of those negative symptoms and potential exposure to the disease. These are organized on the Track and Trace application through a very simple central question, which is, how are you feeling today? And that then extends towards the second set of symptoms if you respond in the negative. So if you're responding to anything other than I'm feeling great, you are then asked to indicate whether you have a high temperature and a persistent cough and the date at which you began experiencing those symptoms. And if you answer in the affirmative to those questions, then information is sent to the NHS database that you may have been exposed, and that information is stored by the NHS. Prior to that information being shared with the NHS, all of the information about who you have been in contact with to date through the Bluetooth tracking that I mentioned on the previous screen is stored locally on the device, and it's stored there for up to 28 days. The third sort of aspect of this application then is the alerts and the risk scoring that occur after this point. So if you have negative symptoms, a notification is sent to the NHS, and then the NHS sends anonymously to other app users who you have come into contact with the information that someone that they have been in contact with has reported these symptoms to them. There's a couple of important characteristics to this feature. The first is that the notifications are decided by a proprietary algorithm that has received sign-off from the Chief Medical Officer, Chris Whitty, and that was developed in Oxford University's Departments of Medicine and Population Health, and is a regularly changing algorithm that is intended to be reflective of the risk profile of the national exposure to the disease as a whole. So it is intended not to just be a one-size-fits-all distribution of notifications to proximity contacts. Instead, there's a filtering process to determine which of the contacts that you have been in contact with most need to receive the notification. And some of the variables that can go into that are the length of time since you were in contact with them, and how many times you were in contact, and the potential proximity. The last thing that's important to understand about the NHS Track and Trace application is how they handle data storage and privacy. It's a big part of all contact tracing applications, and as you would expect, it's crucial to the NHS. The COVID-19 app, as it's designed, holds no personally identifiable information about you, and you will remain fully anonymous, so that's an important feature of it. The unique IDs that I mentioned from the Bluetooth tracing are stored locally on the device for 28 days, And these are only shared with the NHS if you report the negative health symptoms. So that's an important data storage and privacy feature. And then the other thing is that there's a postal district that is captured by users at the entry of the application. And that postal district is just the first section of your postcode, so it is not your full address. And there's about 8,000 or so addresses in each postal district. So that is an important distinction about personally identifiable information that is not deemed to be personally identifiable, but it is still information about the user. This data is then stored in a secured database, as I mentioned, under what is a centralized model. We wanted to talk ever so quickly before I hand off to my colleague James about the differences between decentralized and centralized models, as that's an important conversation point around these applications generally around the world. The first point to make here is that a decentralized model has a mechanism by which it can understand and then translate the value of a contact tracing application to other users of that application without control or storage of information from a centralized authority like the NHS database is. And it was deemed in the design of this application that that would be a model that was insufficient for the kinds of analysis that were required to do the sorts of contact tracing that the NHS track and trace program would need. And as a result, they've opted for a centralized data storage model instead. You can see some details about how that model functions in the diagram on the screen at the moment. The simple sort of understanding of how that function really materializes as value for the users is that the analysis process of who will receive notifications and any additional security practices that need to be put into place to make sure that the data is responsibly held can all be implemented in one place through an NHS-controlled database. I think that the cleanest and simplest illustration of the privacy and security implications of this sort of trade-off between centralized databases and decentralized data models for this kind of an application are highlighted in the security documentation of the application itself. And while it is a different model to use centralized storage to fully decentralized, there is a lot of work that you can do in designing your application, even if you're using a centralized database. And the NHS has purported to have been working very hard to try and realize some of those privacy and security features. The first of these is that despite the fact that the app is only dealing in anonymous identifiers, the backend is very secure, as would befit an NHS government database. And it's built to NHS standards for protecting personal data. Access to that database is very carefully controlled. In addition, there's no easy or functional understanding of a way that you could re-identify the users of the track and trace application through the function of the app as it is currently architected. There is a piece of it that we will talk to in a moment about building out of social graphs from the centralized storage of who has been connected to whom once the user has reported that they've been suffering from symptoms. And we'll speak to that in a moment. But if identification of a user with the NHS happens through this app, which may happen in the future through things like the incidences of recordings of testing, this system uses a privacy-preserving gateway that will make it so that you can link a test to an app installation ID, but not the installation ID to the user's personal identity or their health record independent of this application. There's two more things. One is that the architecture for this system uses a commercial front end to provide, among other things, load balancing and direct denial of service protection. And that means that the front end, the commercial front end, does have access to the IP address of the phone on which the application has been installed. But that IP address is never exposed to the NHSX backend system, which is an important part of the design of this application, as it is for all contact tracing apps. And as I mentioned earlier, there's no ability in this application, as currently defined, to build a social graph in the traditional sense, but the functionality exists to do pairwise proximity events for anonymous identities. This effectively means that you will be able to identify that two anonymous identities have been in contact with one another, but not that a third anonymous identity was ever connected to one of the previous two. And as a result, you can't build an extended graph out of this system, at least such as the security documentation exposes. And you can learn much more about the security documentation at the link I've provided on the screen there. I think I'd wrap up here by just saying that there's sort of a couple of really important takeaways to understand the track and trace application as it's been put forward by the NHS and by the UK government. The first is that it's a fairly feature-limited application, simply trying to restrict itself to Bluetooth tracing and simple symptoms sharing back to the NHS, and that it uses that simple sharing to then generate alerts for those who may have been exposed to COVID-19, and that it does so in an architecture that is centralized, but that is very secure. Anonymous data is safely stored by the NHS and GCHQ, and that security is an important part of the design of that database. And then the final piece is that this application is still in flux and has not been achieved or sent out for wide distribution yet, and that many changes are still occurring as it is developed. Thanks very much.
Thank you, Jonathan. And with that, James, over to you.
Hi, good afternoon. Yes, my name is James Kingston. I'm Deputy Director of the HAT Lab. I'm here to talk about the ShareTrace application, which is a contact tracing and infection risk scoring tool that we've been developing in the HAT Lab. It arose as a result of our Hack from Home, which was a global hackathon that we put together in March, beginning in early April, which brought together hundreds of people from all around the world, universities and partners stretching from Korea to California, all getting involved in ideating on how to create privacy-preserving applications that would be useful in fighting the spread and social effects of the pandemic. We had a number of really great ideas come through from a whole range of applications, but the winner was this idea of ShareTrace, which was put together by various organizations, including Case Western, Reserve University, and individuals from the University of Surrey. And the idea there is to try and find a way of enabling some contract tracing functionality that would also preserve people's privacy and also use network analysis and social graphs ultimately, I suppose, to have greater analysis of what's going on. Right now, there's been this ongoing debate, as we see it, between many people who want privacy and so favor, by and large, decentralized systems, and then the governments and scientists who have been in favor of centralized systems, arguing, of course, that centralized systems enable better analysis. And we've spoken to certain epidemiologists who'd argue that decentralized systems, including some of the main models that you can see, or the protocols coming out through Google and Apple, etc., won't be that useful in digital contact tracing because of the inability to do the large-scale analysis you need back at the center. So this really was an attempt to try and deal with some of these problems, try and square that particular circle of needing some centralized computation with wanting to undergird and maintain people's privacy. And so the ShareTrace team, which is initially known as SafeTrace, but sort of changed the name in order to make it seem more intuitive, what we're trying to do. What they do is they have built a solution based upon people's personal data accounts. So this is the technology system, the hub of all things based technology system offered by Dataswift that gives every individual a personal data account, i.e. a space where they can legally own and control their data. And then they use that space to contribute their data relevant for the application to the app itself, and then from the app to use that as a identifier for some back-end computation, which I'll show you a bit more about in a moment. So it's all been a pretty interesting ride. Work on it is still ongoing. We're expecting to have our first testing release next week, and then a fuller release a few weeks after that. But what I'd like to do in the next 3 slides or so is just to kind of outline a little bit more about where we see some of the key problems as being, and where we think ShareTrace can help. So that's actually gone, I think, a slide further than I intended it. But basically, yes, thank you. The current app models that we have, so I've already highlighted, you have the question of data storage. Is it decentralized, usually on people's phones or potentially into the cloud, and is it centralized? That's the first kind of issue. But then you have a broader question around the nature of the applications themselves. If we look globally at how digital contact tracing tools have been used, they're often quite similar to manual contact tracing. It's really a digital enablement of pre-existing systems. It's working out, someone's been tested, it's then finding out everyone who that tested positive person has been in contact with. In traditional contact tracing, you do this over the phone. You have a bank of contact tracers calling up people. A lot of the digital contact tracing tools that we see, they use Bluetooth or some other system to try and gather that data. But this is highly reliant on several things. It's reliant upon people getting tested, which, as we know throughout the world, has been a bit of a problem because there haven't been that many tests available. And it also relies upon those tests being processed rapidly, because if it takes 3 days, as you can see on the graph here, for someone to get tested and to be notified, then you have a problem. The virus can very rapidly move. And it's something that's as infectious as COVID-19, that presents a very large problem. Can you move on to the next slide? So one of the central ideas behind ShareTrace, along with having this sort of data ownership, preserving infrastructure of the personal data accounts, is to use interaction graphs. So it's to enable, to use these personal data accounts to enable a network propagation model. And the idea is that any user of the app can start logging their symptoms. What this symptom can be used to do, even in advance of them getting any test, because again, we have this scenario where a lot of people weren't able to get the tests on time. If I start saying that I have a persistent cough, maybe that I can't taste anything, I log that for a day, my risk score goes up. But then also the risk scores of everyone who I encounter in that time also goes up, meaning that I, as a symptomatic individual, can firstly alert those around me, anonymously of course, to their updated risks, and then people whom I've met and infected who are currently asymptomatic, that in turn they can influence the risks of those around them who come into contact with them as well. So it's a very different approach on the back end. Can you move on one more slide? So this is a little bit more. I've plucked this from our white paper, which you're very welcome to come and read on the sharetrace.org website. That's sharetrace.org if anyone's looking out for it. Hence why it has a number 5 here, although as you can see there wasn't 5 slides. This is just a little bit more upon the propagation that I just mentioned there. So you have, if we look on the right hand side, there's a user who's tested positive. User 5 is now reporting some symptoms or has a higher risk. User 5 has hung out with user 2 and user 1 as well. All of these people, all of their risk scores now change dynamically across their network, meaning that everyone can gain a greater appreciation of the risk that they are infectious and take actions accordingly. So it's all about giving people the tools to know if they've been exposed, and then to give them a set of options around what they should do if they have been exposed. Can you click on to the next slide? So here's a little bit more on what it actually looks like as a broader architecture. So I've mentioned this concept of a personal data account, and that really is what we think makes us very special. At the beginning of this little spiel of mine, I talked about this distinction between the needs, the kind of balance that people are trying to find between privacy and then also being able to conduct large-scale analysis of data, which a lot of epidemiologists would see your more decentralized approaches as failing to enable. Well, we think we actually can help with that due to our architecture. So if we look at let's say the individual in orange, just for the sake of argument, because it's at the top, that individual is putting their symptom data and also their Bluetooth encounter data into their personal data account. So that personal data account holds that data. The individual owns that personal data account and can set permissions for who can read that personal data account and write into it. That personal data account therefore functions as, in a sense, a kind of decentralized, centralized space for the individual. So everything is centralized about that individual's data, but of course, because it's about individuals, it's decentralized. Now, each personal data account, when it gets the data from the individual on their symptoms, can calculate a risk score based on that. It then uses the risk score as basically an anonymous identifier for the individual, which it sends alongside the Bluetooth encounter history to the ShareTrace server. There at the ShareTrace server, which enables that more sophisticated central computation we were referring to earlier, individuals can be matched to one another. So, if I have a cough and I've bumped into, I don't know, someone on the street, or well, not on the street, say at a pub or coffee shop, either they're my friend or I just sat next to them. The fact that we will have had our Bluetooth on means that the system will know that we've communicated. And so, because I've been coughing, that other person whom I've met can now have their risk score updated as a result. And so, within the system, that gets analyzed, the scores gets matched. No identifying information is put into the system. Let me say that, again, it really is just the score and the contact history. And then once it's updated, it gets propagated back down to the personal data accounts, and it can then be accessed and read by the individual through the friendly user interface that we have on the ShareTrace system. So that's the core of the idea. I could wax lyrical about various other elements of it at length, but suffice to say, it's a system that's been picking up a lot of interest. We have a couple of local authorities in Ohio who are going to be working with us to roll this out, and a range of other entities and individuals who are very excited about what they can see as possibilities of this tool. And I think it helps solve quite a few of the problems that people have been identifying of DCTs.
Terrific. Thank you, James. So with that, what I would like to do is take, we're just a couple of minutes over, but we'll have a brief Q&A. And by all means, for those of you participating today, if you will either use the chat function to Vinicius on the participants list, or simply flag your hand up, we will be delighted to take your question. So Jonathan and James, I'll start with what is probably the most difficult question to answer in an unbiased fashion, given that we have a horse in the race, as it were. But from either of you, both of you, what are your thoughts on which approaches philosophically, technologically are winning? So is there a clear sense, if we look at governments, if we look at private industry, as where the winds are blowing?
I think, if you don't mind, James, I'd like to jump in quickly. I think that it's hard to say that anyone's winning at the moment, Sean. These are very difficult and pretty new technologies to be implemented. And there's a couple of cases that have seen some wide rollout and some good success so far. There's an application that was rolled out by the Australian government that saw over 1 million downloads. The French contact tracing application was just rolled out to more than 1.5 million downloads. And the UK model is sort of a much more centralized and fairly straightforward technology infrastructure that has seen a lot of challenge that has come from its centralized infrastructure. And so I think that, that's a complicated way of saying that there's no definitively right answer right now. I think that there are some really strong arguments that the ShareTrace model has put together, as the way James has illustrated it, for being able to do richly featured applications without building in a centralized data storage sort of system. And then similarly, when you're building in a centralized infrastructure, there's a lot of arguments as to why the simplicity that comes from that architecture is very valuable if you can solve the trust problem. And at least by my estimation, in diving deeply into the track and trace app, the biggest issue it's going to face, and it is currently facing challenges around this, are that either people will have to decide whether they trust the NHS and the UK government data storage systems as an application provider at all. And if they do, then I think the centralized infrastructure is perfectly sufficient for delivering this kind of functionality. But if for whatever reason that trust goes away, or if it's not the kind of approach that the users of the application have, it will really struggle to see mass adoption under this model.
Appreciate it. We have a question from the audience from Alex Rice-Corey, who in his registration here we see as a human factors researcher, so a terrific person to be asking this question. And that is, how have we approached reducing initial user friction? He references the medical pressure, downloading the application, various attributes of what might cause user friction, and what communication and intervention strategies are working to encourage reluctant individuals to adopt. Great question. Thanks, Alex.
Yeah, it's really
good.
I think
certainly from our side, this, as Jonathan flagged, there's the question of trust. People have to really want to use the application. And you have to think why. A lot of governments, particularly initially in the crisis, and I dare say they'll do so again, were able to use a narrative of, firstly, it's the government, you should trust it, and then this is a national collective effort. I had a friend text me and say that he was going to use the NHS app when it came into Britain as a whole, simply because it's the right thing to do. So there's a sort of moral pressure and trust there. But people's views on what's happening change, particularly trust in government's capacity to look after the data well. I'd say people need to know that the data is secure, that they can delete it, they can remove it, that it isn't going to be sold or moved on or kept forever without permission. These, I'd say, are quite important things to be able to be communicated at a high level. But ultimately, I think a lot of consumers don't really care too much about that. They trust other people signaling perhaps around those points. You have to persuade influential people, but it's just having a good user interface and seeming trustworthy in your communications.
I completely agree. And I think I would add to that by saying that, one of the challenges that applications tend to face, all applications, not just context tracing and immunity passport apps, is that if you want to signal great privacy, typically under old architectures, that meant reducing functionality and reducing data exposure. And in an application like these, that's just not possible if you want to be truly user-focused, because you have to be delivering things that use a substantial amount of information to go beyond just, who are the proximity-based contacts that you've had over the past couple of days or months. And so it's becoming not acceptable anymore to have low feature or low function apps in the name of privacy. You have to have both privacy and function.
Absolutely. And I think it's interesting. Go ahead.
Well, I just add one more detail on that as well, which is that, a lot of, globally, as we understand, a lot of the digital contact tracing apps, you really are just giving your data to the government or the public health authority, and then you maybe get some set of instructions possibly coming back down to you if you've been infected. In the share trace instance, you'll be given a user interface and you'll be given your own personal risk score and exposure score. So there's some value to the user, irrespective of what's happening further on in terms of analysis. And I think people trust that.
Absolutely. Yeah, I'm reminded of, not that I'm an expert, but the concept of a Schelling point, which in game theory means we are at a place where I think it's going to bear out what populaces in various governments, who they trust, where they put their faith. And I think Jonathan and James, you raised two excellent points about the impact of, or the effects of believing it is one's civic duty, trust or distrust of one's government, and the simple consumerization of everything, which says that if the application is not beautiful, is not easy, is not compelling, dare I say even gamified in some way, that we may not adopt it. We have another question from Steve Garvey, which is, and I'm not fully familiar with this study, but perhaps Jonathan, James, you will. He asks, references the King's Zoe NHS symptom study in the UK, has 3.8 million contributors, and asks, could this user base be accessed for a contact tracing application?
I mean, I can certainly speak to that a little bit from the from the track and trace app. The implementation of the application across the UK population isn't the challenge facing the app at the moment. you know, the solution to some of the architecture challenges that they've faced, and to some of the sort of the human rights challenges that have sort of been brought against an application that centrally stores user data in this way, are what they're currently trying to tackle. As those get solved, the sort of move forward into wide distribution will be much more straightforward. And certainly I believe that integration with some of the academic initiatives like the one you're describing there will probably be a healthy point of entry. You know, the challenge again will be a little bit about what data is accessible in what kind of capacities to what kind of parties, but the rollout through those kinds of surveys will absolutely be a path to market.
And I'd add on that point, the ShareTrace version 1 model is based upon data gathered and a model generated through that study, through the data collected by Zoe.
And just quickly, I'll pause. We are delighted and will stay and take as many questions as you have. For those who do have to drop off because you have other commitments, I just want to say thank you for taking the time. We greatly appreciate it. You'll receive a follow-up from us, I believe, Vinny, with a recording of today's webinar that you're welcome to share. But with that, we'll keep going. Just a follow-on comment from Alex Rice-Corey is, you know, says, thank you, coming from the perspective, and I think this is excellent, that the Cambridge Analytica scandal poisoned the well. Implicit trust is taken for granted, and I think, you know, the point I take away from that is we have to earn it each and every time.
Yeah, and again, I'm trying to speak very much from the track and trace perspective here, and you know, trust is a thing that is earned mutually with your users, and I think many in the public health domain would agree that the mechanism by which we can develop a system by which a trusted institution like the NHS can better keep people safe and healthy and reduce the spread of this disease throughout our system is sort of the end goal here. And developing trust in that way is a very important part of sort of trying to achieve a good public health outcome here. I think that, you know, there is an element of public trust that faces just using the application at all. And absolutely, we need to talk about that, and we will see in practice exactly how real that is. But then there's a second layer of public trust that will come from when the application is used. You know, can it deliver the outcomes that it needs? And we need to meet both standards of trust to be successful here. It's not sufficient to just have people use the app if the app doesn't then help. And it's not sufficient to have the app be helpful if people won't trust it enough to use it. So both have to be met simultaneously.
Excellent point. And I think unless there are other questions or comments from the audience, then that's a wonderful place to wrap it up. Thank you, Jonathan. Thank you, James. Thanks again, everyone, for participating. And we will look forward, I'm sure, to seeing you on another webinar very soon. Have a great day.
Thank you, everyone. See you soon.
Bye-bye.
Bye-bye.